Hello everyone, it's John from IT Skills Academy. A common problem encountered in programming is the need to search an array in order to find the location of the desired value. In C, you can use two search algorithms to solve this problem, that is, linear search and binary search. In this video, we'll be discussing the binary search algorithm. First, we discuss how this algorithm works. Later, we write the code. Feel free to skip using the timestamps in the description of this video. Binary search works with a sorted order. This search doesn't need to scan the whole array. In this video, we are searching for an array that is sorted in an increasing order. Binary search works with a sorted order. This search does not scan the whole array. In this video, we are using an array that is sorted in an increasing order. Now let us name our array A. Now the size of our array is 8. Now our target value is 5. Let me just make this a little bit bigger so that you can see. So 5 is our target. So this is what number that we are looking for in this array. Now in the implementation of the binary search algorithm, we usually use two variables. That is the first and the last. Now the first and the last usually helps us to know the end and the start of our sub array. Now through the first and the last, we can be able to get the middle element, and with this middle element we can be able to get the border between the first and the last. Now how do we get the middle element? It's usually very simple. To get the middle element, we usually take the first number. In our case here, the first number is 2, while the last one is 23. So here we come and take the first number and we add it to the last. So we are calculating the middle, which we are saying is equals to the first plus the last, all these divided by 2. So in our case here, the first is 2 while the last is 23. So this gives us 25. So now to get the middle, we are dividing 25 by 2. So this should give us 12. Now we already have our middle number, so we can just come and say here we have the middle being equal to 12, and our target is 5. Like, this is the number that we are looking for in this array. Now what the binary search algorithm will do after getting the middle number is that it will equate the middle number with the target. So in our case it will be 5, or whether 5 is equal to 12, and this will be equal to false. So now the algorithm now will move to the next step, and in the next step it will now check if the target number is less than the middle number. So that is if the target, that is 5, is less than 12, and this will return true. So now this will mean that the binary search algorithm will scan the first half only. So remember, here we have the first half and here we have the last half, because we have the border in between here, because our middle number is 12. So now the binary search algorithm will continue to search the target value here. So if it finds a target, in this case it will find 1 here, it will return the position of the target. So in this case, if we label these arrays starting from 0, all the way to 7, then the result will be that the position of our target value is position 3, or rather 2, because we are counting from 0, 1 and 2. So our target value will be found at position 2. What if 5 was not less than 12? Then what would have happened is that the binary search algorithm will have checked if the target is greater than the middle. So if it is less or if it is greater than the middle, this will have meant that our target value is in the last half, and the binary search algorithm will have searched the last half. Now let us try to write some code and see how this is implemented. Now we are writing the binary search code that will help us to search for a value in a given array. So the first thing that we do is to get the method, or to create the method that will be used to search. Now the first thing that we are going to do is to give the method a name and data type. So we are going to give it a data type of int, and the name will be just binary search, and within brackets we are going to come and have int a. So this is the array within which we will be searching, and we'll also have the variable int n as well as int x. So these are variables that we are going to use later. So now within that, the first thing that we want to do here is to declare the low and the high. So we are going to have the row having a data type of int, and we are going to assign it a value of 0, as well as high, and we are going to assign it a value of n minus 1. Now after that, we are going to create a while loop that will iterate through the array. So we are going to just come and say while, and the condition for our while loop will be if low is less than or equal to high. So now within the while loop, and if row is less than high, the first thing that we want to do is to get the middle element. And to get the middle element, we are going to declare it here and say int mid, and this will be equal to low plus high. So as we have discussed earlier, to get the middle element, we will be adding the low and the high variables, and then divide all that by 2. And now that we have the middle element, we can match that with what the user has or is searching. So we are going to use an if statement and say if x in this case being the value that is being searched, or the target, is equal to the mean of the middle element. So if it is true, then it should return mid. So this will mean that we found our target. Else, if that is false, so else if x is less than the middle element, then we should return high is equals to mid minus 1. So now this will mean that our target is before the middle element. Else, if that is not true, then now this will mean we should not have these curly brackets. Else this should return low is equals mid plus 1. So now this one means that the target is after the middle element. So now this means that the binary search will scan the last half, while in this case it will scan the first half. Now if all that does not go through, then it means that we don't have that value within the array, and so it should return -1. So now that is the method that will help us to search for the value. So now we move on to the main function. So I'm just going to come and say void main, and now within the main, the first thing that we want to do is to declare the array, or create the array rather, and the array should be equal to a set of curly brackets. Then we should have the values 2, and now that we have the array, we can request the user to insert a given value, so, or the value that they want to search. So I'm just going to come and maybe have a tab there and say please enter a number. And the other thing that we're also going to do here is to again declare another variable x with a data type int, and after that now we want to come and store whatever the user has entered. So we're just going to come and use the scanif function just like that. And then now after that we now want to call our method to help us in doing the search. So we're just going to come and say int IDEX. So we are creating a variable called IDEX with the data type int is equal to, so we are assigning it the function, so that is the binary search, and within the brackets here we should have first thing that we should have here is the name of the array, which in our case is A. Second thing is the size of the array, and that is the value that we are searching. So in this case it is being represented by x. Now that we have already assigned the IDEX the function binary search, we want to check if this function returned a -1. So if it returns a -1, then it means we don't have a result, like the value that you're searching for is not within the array. But if it does not return a -1, then it means we have some results. So how we are going to do that is we're just going to come and create an if statement, and then here we just come and say IDEX, or the condition will be if the IDEX is not equal to -1. So if it is not equal to -1, then it means that we have some results. So it should now print the results. So we can just come and say that a number, whatever number the user has entered, is in position, whatever the position it will be in. And then here we are going to come and have the search number, so that will be x, and its position, so that will be a target. Sorry, that will be IDEX. Now else, if this function returns a -1, then it means we don't have results. So then we should come and say print if the number that the user has entered is not found. And we should also be able to get that number, so X. So now we'll compile the code and run it to see if it is working. And here we are requested to enter a number, so we just come and enter number 4, and we are being told that number 4 is in position 2, which I don't think is right. Let's try to enter position. Let's try to search 50. So if I try to search 50, it's telling me that number 50 is in position 4. So if I count 0, 1, 2, 3, 4, 5, 6, so that means it is long. So the simple mistake that we've made here is that we should not have the return here. So if I fix that and run it, and then now we try to look for 50, and that should give me position 6. So if I count 0, 1, 2, 3, 4, 5, 6, so that is right. So 50 is in position 6. And if I try to search for a value that is not here, so say for instance 77, it should tell me that the 77 is not found. So there's some errors that you can make while you're creating this code, as I have already done. So like for example, you should not have the if statements with the curly brackets like we have in this case. That's one mistake that you can quickly make. Then you should also not have the else with the return like we have in this case. So if you do that, then you're going to have your binary search returning the wrong results. Some other common problems is if you start with high here instead of low, or you maybe fail to declare the low and the high. So those are some of the common problems or common mistakes that you can make while you're creating this code. Otherwise it should work well. So that's it for this video, and as usual, see you in the next one. Thanks for watching.